Hello everybody. In this lecture we are going to discuss Woodward hydroxylation and Prevost hydroxylation. These are the diol forming reagent in which the Woodward reagent, that is iodine with silver salt of carboxylic acid, generally acetic acid, silver salt of acetic acid, in dry condition, in wet condition gives cis diol, and same compound, same combination of compound, that is iodine in silver salt of carboxylic acid in dry condition, or which is called as a saponification, gives a trans diol which is called as a Prevost hydroxylation. Hydroxylation or diol formation means in which across carbon double bond two OH groups are obtained, two OH groups are introduced. See, the silver salt of carboxylic acid in dry condition with iodine, that is Prevost reagent. Here we get the trans diol. See, this is a carbon double bond, that is alkene, and we get here diol. The two OH groups are at antiposition to each other, so it is a trans diol. Here this is carbon double bond, iodine, silver salt of carboxylic acid in dry condition without water molecule, and then followed by hydrolysis in alkaline media. Here also we get the trans diol. See, the two OH groups are added across carbon double bond, but the stereochemistry is important. Here this one OH group is shown by dark line and another is shown by dotted line, means they are trans to each other. Cyclohexene, and at the third position methyl group is there. So it is 2,3-methyl cyclohexene. And using the Prevost oxidizing agent, OH groups are added, and that is the stereochemistry trans. Now it is interesting to show that how to show the trans diol here, whether to show this OH group with dark line and this with dotted line, or vice versa. So it is obvious that as this methyl group is facing toward the observer, it means this OH group which is adjacent to this carbon should have the opposite stereochemistry. That's why it is written in the dotted line, and the another OH group is shown by dark line, because they are too much away from each other. Okay. See this one. Here across carbon double bond diol formation takes place, and what is the stereochemistry? Trans. Here three carbon double bonds are there, 1, 2, 3. So when we treat it with the Prevost reagent, see, this is the conjugated, this is also conjugated carbon double bond. This is alpha beta unsaturated ketone. See, this is carbonyl group, this is alpha carbon, this is beta carbon, and there is a pi bond in between alpha and beta. So it is alpha beta unsaturated, and it is conjugated because these pi bonded electrons were shifted on oxygen, this carbon will deficient, these pi bonded electrons will shift here. Similarly, this is also in conjugation, because see, double single, alternate double single bonds are there. So conjugated compound. The conjugated carbon double bond does not oxidize by the Prevost reagent, they remains as it is. Only this unconjugated or non-conjugated carbon double bond get oxidized to diol. And what is the stereochemistry? Trans stereochemistry is obtained here. Okay. Now see the mechanism of this trans diol formation by using the iodine in silver salt of carboxylic acid in dry condition, which is also called as a saponification reaction. Okay, see, this is our alkene having the cis stereochemistry. This is iodine. This is a silver salt of acetic acid. And see what happens here. In the first step, there is a formation of iodinium ion takes place. What do you mean by iodinium ion? Iodinium ion is the three-membered cyclic ring where the iodine is sandwiched or trapped between two carbon atoms, having a positive charge also. Why there is a deficiency of over the iodine? Because iodine forms two bonds here. Actually, the valency of iodine is 1. And it have the 3 lone pair of electrons. So it means one lone pair is utilized here in the formation of bond, and that's why it have the positive charge. It is a deficient. So this iodinium ion is formed. How this iodinium ion is formed from this alkene on treatment with iodine, that is interesting to see. See here, this pi bond is open on the carbon, so it have the negative charge, electron rich. At the same time, iodine bond cleavage takes place, so it is a deficient. So this is rich, this is deficient, bond is formed. And what is the charge on this carbon? When these pi bonded electrons are shifted on carbon, it is a positive, deficient. And iodine donates its lone pair to the carbon. So this happens simultaneously. Formation of carbon iodine bond and formation of this new carbon iodine bond between deficient carbon and iodine by the donation of lone pair from the iodine takes place simultaneously. And this I negative, that is iodide ion, leaves the moiety. And that iodide ion and this silver ion, Ag positive ion, combines together, there is loss of silver iodide. Okay, and this acetoxyl ion, or we can say acetate ion, is also eliminated, and we get iodinium ion. Now, as I told you that this CH3 C double bond O negative, that is acetoxyl ion or acetate ion, it is now nucleophilic in nature. Now it attack from the backside. This is a SN2 type of attack. When this new bond is formed between oxygen and carbon, this nucleophile oxygen and this carbon, at the same time this carbon iodine bond breaks, cleavage takes place, and iodine gain its lone pair. What is the driving force for this formation of this new bond? The driving force is that the iodine is deficient because it have donates its lone pair to the carbon. In the moment, in the next step, it will gain its lone pair, carbonium ion formation, and this new bond formation takes place. This happens simultaneously. So bond cleavage and bond formation, and we get this moiety. Now see here that it is iodoacetate, because to vicinal iodoacetate, to this carbon iodine is there, and to the adjacent carbon there is a acetate ion, acetate group is attached. And what is their stereochemistry? They are anti to each other, they are opposite to each other. That's why these are called as a trans. Therefore the word is used here, trans. It is a trans iodoacetate is formed. Okay, trans iodoacetate is looking stable, but it is not so stable. What happens in the next step? See, this oxygen, we know oxygen have the lone pair of electron, two lone pairs are there. So oxygen donates its lone pair to the carbon, and there is a elimination, there is a removal of this iodide ion, I negative. So it is again SN2 type of attack. We can say it is a neighboring group participation. Oxygen donates its lone pair, and there is a removal of iodide ion. What happens when oxygen donates its lone pair? Oxygen will bears the positive charge. Deficiency is created here. Okay, and there is a removal of I negative, and we get this intermediate. Now here in this intermediate, you can clearly see that oxygen is deficient. What is the ring size? It is a 5-membered ring. Now in the next step, the another molecule of this ester, this acetate ion attack on this carbon. It is again SN2 type of attack from backside. Now the question arises, why this attack takes place from backside? Because from this side, backside of what? This acetate ion. To avoid the steric hindrance, to avoid the crowding effect, it attack from the backside. So when this new bond is formed between carbon and oxygen, this is a nucleophilic attack, SN2 type attack. At the same time, this oxygen carbon bond will open on the oxygen, oxygen gain its lone pair which is previously lost. What is the driving force for the formation of this bond and the detachment or the cleavage of this bond? Deficiency of the oxygen, deficiency over the oxygen is the driving force. So oxygen gain its lone pair and the bond is formed. Now we get this. What is this? It is a trans diacetyl derivative of this carbon-carbon double bonded compound, that is alkene. What is called as a trans? Because the two acetyl group are at opposite position across carbon-carbon double bond. They are 180 degrees apart. That's why diacetyl derivative of that alkene. Okay, this is the first step. And the second step, hydrolysis. On hydrolysis, this oxygen carbonyl group, this oxygen carbon bond cleavage takes place. It will oxidize to OH group. Here similarly, this oxygen carbon bond cleavage takes place. It will convert to OH group, and we get the diol. Interesting to see the stereochemistry. The two H groups are opposite to each other, that's why it is a trans 1,2 diol. 1,2 indicate the position of this two H group with respect to each other, which is also called as a vicinal diol. Trans 1,2 diol is obtained. This is the Prevost reagent, mechanism of Prevost reagent. Okay, which is also called as a Prevost, it is also called as a saponification. Okay. Now, let us see Woodward reagent. Woodward reagent, the condition of the Prevost and Woodward is different. The reagent is same. Here also iodine in silver salt of acetic acid is there. Only their difference is that there is a dry condition, here is a wet condition. Means water is there. Okay, so to avoid the confusion, you can remember if water is there, it is Woodward. W stands for water, W stands for Woodward. Okay, so Woodward reagent. So see, this is the carbon-carbon double bond. It is oxidized to cis diol. Two H groups are on the same side. Here it is carbon-carbon double bond. Two H groups are added across same side. So it is we get diol. What will happen if this methyl group, which is the part of the precursor itself, if it is shown by dark line, means it is toward the observer. In that case, you have to show these two H group by dotted line. Okay, so as to avoid the crowding effect that will happen. Yes. See, it is carbon-carbon double bond. This is a Woodward reagent, iodine in silver salt of carboxylic acid, followed by hydrolysis in acidic media. Here also we get two H groups are on the same side, that is diol formation, carbon-carbon double bond, two H groups are added. Now see the mechanism of Woodward reaction. What is the difference between the mechanism of Prevost and Woodward? Why there is a trans diol formation and here cis diol formation takes place? The first step is same. I will not repeat this because it is same as that in the Prevost, where the iodinium ion is formed, three-membered cyclic intermediate having iodine trapped between carbon-carbon double bond. Second step is also same, where this acetyl ion attack from the backside of the iodine, SN2 type attack, where the bond formation between this acetyl or acetylic oxygen of the acetyl group and the cleavage between carbon iodine bond takes place. I told you that the driving force is the deficiency of iodine in this case. It is SN2 type attack, we get trans iodoacetate. After that, the third step is also same, where this oxygen of the acetyl group donates its lone pair to the carbon, oxygen carbon bond formation takes place, SN2 type attack, and the breaking of carbon iodine bond, that is removal of iodide ion. It is a leaving group and it is the incoming group. As oxygen donates its lone pair, what is the charge over the oxygen? Positive charge, it is a deficient. This is the again same. Now the fourth step onward, there is a difference in Woodward. What was the fourth step in the Prevost? In the fourth step, another acetyl ion, acetyl moiety attack from the opposite position, that is from the back side. But here in this case, instead of that, water molecule attack takes place on this carbon. As oxygen is deficient here, oxygen gain its lone pair because oxygen is more electronegative than carbon, and the carbon becomes positive, that is deficient, and the carbonium ion is formed, it is carbonium ion. The moment the carbonium ion formation takes place, this water molecule donates its lone pair, oxygen donates its lone pair to the carbon. What will happen after formation of this coordinate bond between oxygen and carbon? Oxygen will bear the positive charge, that is deficiency. What is the name of the intermediate where oxygen have the positive charge? It is called as oxonium ion. Stable or unstable? Unstable. Obviously it is unstable. And the next step, deprotonation takes place, where the proton, that is hydrogen atom, departed from this oxygen without electron, means oxygen gain its lone pair and we get this OH. Now oxygen is stable. Here everything is looking stable. There is no positive or negative charge is there. But till it is unstable, because this carbon is attached to 3 oxygen atom, that is electronegative atom. And you might know that if the carbon is attached to two or more electronegative atom, in that case, due to withdrawing nature of that electronegative atom, deficiency is there, and it is unstable, and now it try to stabilize itself. So what happens, see, here the ring opening reaction takes place and the bond cleavage takes place. Here see, this carbon oxygen bond cleavage takes place. This bonded pair of electrons are shifted on oxygen. Oxygen have the negative charge, means excess of electron. Carbon have the positive charge. At the same time, this oxygen hydrogen bond cleavage takes place. This bonded pair of electrons are shifted here. So pi bond is formed between this carbon and oxygen, and this deprotonation takes place. Now this proton, that is S positive ion, and this O negative and H positive OH is formed here. We get this. What is this? It is a cis hydroxy acetate, because hydroxy group and acetate group are on the same side. That's why cis is written there. It is a geometrical isomerism where the OH and ester, that is acetate group, are on the same side. That's why called as cis hydroxy acetate. Now this cis hydroxy acetate finally on a hydrolysis in alkaline medium, as I told you in the previous step there will be the addition of H and OH from the water molecule here, means this carbonyl, the bond between carbonyl group and oxygen will break, disconnection takes place, cleavage takes place, and here OH is formed. In this way the product is cis diol. The difference between Prevost and Woodward reagent is that in Woodward there is a water molecule, while the Prevost reaction is in dry condition. In Prevost we get the trans product, and in Woodward we get cis product. This is all for this diol forming reagent, that is Woodward and Prevost.